Okay, today in Math 30-2, we're going to look at topic 6.2, 6.3, solving exponential equations. We're going to start with example 2 from the book because I don't like example 1. Example 2a says 2 times 4 to the power of 2x is equal to 1 over 32. Well, in this one, we have a base of 4 on the left side. If we can solve this, it would be easiest and best if we could write 1 over 32 to the base of 4 on the right side. Well, first thing we got to do is get rid of that 2 in front of it. To solve any equation, we have to solve for x. Step 1 is to get rid of the 2 by multiplying both sides by 1/2. So if we take our original equation times both sides by 1/2, we will get 1/2 times 2, which is 1 times 4 to the power of 2x, equals 1 over 64. Now, as I said, we've got 4, base 4. So if we can write 1 over 64 now as the power of 4, we know that 4 times 4 is 16, times 4 is 64, so we can replace 1 over 64 with 1 over 4 cubed. Now, 1 over 4 cubed, you'll remember, is 4 to the power negative 3. Doing that substitution, we now have the exponent on one side equals to the exponent on the other side, since the bases are the same. If 4 to the power of 2x is equal to 4 to the power of negative 3, 2x has to equal negative 3. The exponents must be equal. That's where we're going to get our equation from. Now we just simply have to divide both sides by 2, and you're going to get x equals negative 3 over 2, or negative 1.5. It's important that we verify that to make sure we get the right answer. So we can check by substitution. 2 to the power of 2 times 4 to the power of 2x is 2 times 4 to the power of 2 times negative 1.5. That's 2 times 4 to the power of negative 3. 2 times 4 to the power of negative 3 would be rewritten as 2 times 1 over 4 to the power of positive 3, which is 1 over 64. 1 over 64 times 2 is 2 over 64, which reduces to 1 over 32. And that's exactly what the right side of our equation is equal to. So we verified it. Part B. 5 to the power of x plus 2 is equal to the square root of 125. Well, again, let's express 125 as 5 cubed. So instead of the square root of 125, we have the square root of 5 cubed. Now, anytime we have something to the square root, that's the same as to the power of 1/2. So we're going to rewrite this as 5 to the power of 3 to the power of 1/2. And that's going to be 5 to the power of 3 over 2. Just filling in the other side. We now have 5 to the power of x plus 2 is 5 to the power of 3 over 2. If the bases are the same, the exponents must be equal. So we can say x plus 2 has to equal 3 over 2, or 1.5. Subtract 2 from both sides, and x equals negative 0.5. I'll leave you to check that with your calculators. Part C. 9 to the power of x minus 1 is equal to 3 to the power of x minus 3. Again, in order for us to solve it, we have to express these with the same bases. So, let's put 9 into a base 3. That would be 3 squared to the power of x minus 1 is equal to 3 times 3 to the power of x minus 3. And now, if you have a power raised to a power, the power laws tell us that on the left side we're going to multiply those exponents to get 3 to the power of 2x minus 2 equals x minus 3. Now we can set our exponents equal to each other. 2x minus 2 is equal to x minus 3. Take away an x from both sides, leaves us with x minus 2 equals negative 3. If you add 2 to both sides at this point to isolate the x, you'll be left with x equals negative 1. And that's our solution. Again, we can check by substituting. And if we did that, 9 to the power of x minus 1, well, negative 1 minus 1 leaves us with 9 to the power of negative 2. On the right side, 3 to the power of x minus 3, negative 1 minus negative 3 will leave us with 3 to the power of negative 4. 9 to the power of negative 2 now is 1 over 9 to the power of positive 2, which is 1 over 9 squared, which is 81. 1 over 81. The other side must be 1 over 3 to the power of positive 4, which is also equal to 81, and so we've proven our identity. Your assignment for Monday is to do page 362, numbers 4 to 7.